how many degree poly we saw? How many degrees poly we saw, guys, yesterday? 0 degree, not 2 degrees. So what we got? We got constant line, isn't it? So let's do it again. I hope you see my screen. And this is what we understood. Okay. So let me execute this one. NumPy, Pandas, Matplotlib. Okay. This is where I got. And let's read the data frame. Okay. So here we go. This is what we read the data frames. Which one is not important? Positions and level. Which one is not important? Positions, because yesterday I explained you this one. And 1:2 means what? So I want to independent variable as a level. So this is do not want, and I don't want this one as well. Okay. So let me select this and independent variable and dependent variable. So the data frame is split into 2 parts. So I think I already explained this one, right? So if you notice this one, and also we build simple linear regressions model, and we build polynomial features we used for polynomial regressions. Okay, what features we are using over here? So let's close this. Just 1 second. Just one moment. All right, so let's close it. Yes. So I think we discussed what features we used. Polynomial features. Let me scroll down. Yeah. So degree by default is 2. In parameter tuning, what was it? By default, 2 degree poly. Yeah. So let's do this today. So polynomial features, let me execute, and degree 0. Yes, guys, degree 0. Let me click this and fit transform X. And we fit the model. So once we fit the model, let's do linear reg 2 for polynomial features. Guys, yesterday I explained you, so that's what I'm just go ahead with a quick one. All right. So let me execute this one. So what we got? This is the linear regressions graph, y equal to mx plus c, isn't it? This is the linear regressions graph. And when I worked on polynomial part, let's do this. What exactly? Straight line. It's a constant line because the x to the power is 0. The x to the power is 0, right? So in this case, what we understood, so if the person's level of experience is 6.5, he should get more than 150K, isn't it? But now for this linear regressions model, what predicts? It predicts 330, which is incorrect predictions, which we saw. Which this one? How much we got this one? I think 250. Yes, 249. So this is also incorrect predictions. So what could be the next step we're going to do? We change the degree. So let's say 0 to 1 bad predictions, right? So 0 to 1, let's restart the kernel. What I would get output, guys? Anyone? What I would get output? Same graph I will get or not? Y equal to mx plus c graph. Yeah. So I do not want to run the script one line by line. Did you see this play button, green color button? Are you see this? If you want to run entire code at once, you should execute this button. Okay. When you deploy, when you execute all the servers, you're going to click this one. Understand, guys? So let me execute this one. See this, the kernel is executing. Yes, it's done. So correct or not, both are got same part, even though linear regressions, we got this one, isn't it? For polynomial regressions also we got one, because both cases degree is 1. Yes, guys. So here, what I would next step? What is the next step? Still the prediction is bad. If you see this, linear regressions, 330. Polynomial, what do you get? 330 only, isn't it? I hope you understand, because both cases, the degree, the x to the power is 1, same, isn't it? Let's do it. I wanted to change the degree to the 2. Okay, degree to the 2 and degree to increase to 2. This is what hyperparameter tune, sorry, parameter tune. So let me remove this. I don't want to put anything else. So let's restart the kernel. Let's restart the kernel and let me execute this one. It's done. One moment. See guys, let's not required. Linear regressions not required. Let's copy image and take it to the paint. Yeah. Oops. What happened, guys? So linear line has little bit curved. So let's see, is this a good predictions? No, because actual point, predicted point is very far, isn't it? So the what we called the error, okay? The MSC values is little bit far over here, far over here, far over here. All those things, understood or not? Yes, guys. So all these points are a little bit far. I hope you understand, correct? So what exactly I'm going to do? Let's compute what exactly my polynomial feature predicted when x equals to 2. I don't want to execute this one because anyway, how much I will get over here? 330 only, right? So 330 only. So let me click and execute this one. 189. Is it a good? Quite good, isn't it? But let's look at this. If the person 6.5, 150 actual salary, if a new employee come to the organization, okay, what exactly my model predicted? 189, isn't it? So I never train my model with 6.5. Have I trained my model? No, right, guys? I never trained my model with these data, but in future I pass 6.5 and my model is predicted 189. I hope you understand, guys. Correct? But still, HR thinks, what is her job? HR job. She trying to reduce the employee's package. Yeah. That's why she got more money because of that. So to it, because if you see this, the person, the level of 7 is got 200, but now the model predicted 189. So what this guy will do, the predictions, so only 2 data points are matched with each other, right? So let me 2, 3. Where is that? Just go up. Yeah. So here degree equals to 3. Yes. I'm done hyperparameter tune. So which was by default was 2, and let me change to 3 and let's do it. Just 1 second. It's restarting. Let me execute entire kernel over here. Let's see how exactly I'll get my graph. Cool. Copy image. So in degree 2, how many points is predicted? Only 2. But in this case, how many points are predicted? Quite better, isn't it? Quite better. Yes, guys. 1, 2. But the curve little bit fit to the all the data points. Little bit fit to the all the data points. But now when you see this, how exactly my model predicted for 6.5, just have a check. 133. No, still very bad, isn't it? 133. Nobody will come for interview. Agree or not, guys? Online team, are you understand? Washim? Everyone? Yes. Now, still it's not convinced. Now, what is the next step? Next step is again increase the degree. So let's restart the kernel. So let me give you. We're trying to check the accuracy which is satisfied or not. That is important, right? So here we go. It's a 4. So when you do 4, let's do this. Perfect. So Control V. So what you found? Every data points are fit with actual equals to predicted. So can I say the sounds good? Can I say it's appropriate model, isn't it? So now what I'm going to do, let's check what exactly my model predicted on this case. So here, let me check 158, isn't it? How much it is giving? 158 and 159, but still somewhere not convinced. So I hope you understand, guys. I hope you understand how exactly we're doing. Let's increase the degree equals to 5. Let's increase the degree equals to 5. Being a data scientist, you can plot a table. You can plot a table and you can say, this is what accuracy I'm getting, right? So degree 2, I'm getting this accuracy. So you can say like to the HR, it's not your job. I mean, it's a business decisions. Your decisions, you have to communicate to them. At second degree, you got this some accuracy. At third degree, you got some accuracy. Fourth degree, you got some accuracy. Fifth degree, you got some accuracy. So let me check the fifth degree. Okay, let's do this. At fifth degree, let me restart. Yeah, it's done. Copy maze, and again same. This should be the optimal. This should be the optimal, means all the data points perfectly fit to the actual points. But still, this is what my model, because we want to create an app. Because all right, so HR wanted to create an app for this. So let's do this. 174. Yes, I think it's perfect, because see, 156th and 7th, 150, 200. So when a person experienced 6.5, of course, this would be the satisfy. Yeah. Neither nobody will say anything. This would be the compromise. So HR can tell you first what HR will tell you. At degree 3, we got 158. Then he got finally not interested. Yeah. Then finally he can opt for 175. Yes, guys. I hope you understand. So this is what the optimal model. I hope you understand what is polynomial regressions. Clear, guys? So what happened if I change the degree to 10? Yeah. So what happened if I change the degree to 10? Because this is the optimal fit. But let's try. What do you think so, guys? Accuracy will increase or decrease? Decrease. Accuracy will increase or overfit? No, it's not overfit, Arshad. This is not the overfit. Okay. So let's try this again. Let's try this again. Let's run this. Yeah, similar. Just one moment. Same point, same graph. But if you see this, 172. Yes. So the finally I can finalized up to 5th degree poly. You say my model predictions 174.8. I mean, it's kind of, I can say 175 percentages and 5th degree poly. And in 4th degree poly, you can say 158. Yes. And in 3 degree poly, how much you got, guys, for this one? I think 189. Yes. In 2, I got also 189, something like this, right? So 132 somewhere I got. I hope you understand, guys. So finally, I can optimize and I build the model and I can say that this is what go for productions. Go for productions. What exactly the next step? The next step is model is ready with the degree, 5th degree poly, 5th degree poly. All right. And using job lib pipeline, and pickle file. All right, you can write a code. You can write a code for Flask API and then create a app. All right, guys. So where model would be the backend and okay, the app would be your front end. All right. And the Flask is the API means middle person. Yeah, I mean broker, I could call it, you know this. And also the pipeline is job link. So we're going to build later part on all the app, guys. Yeah, this is what real time happens. So being a data scientist, you guys will build this model, you create an app. All right, you create an app. So I will talk about Spark, PySpark also. You create an app, RDD, all those things I'll explain in later parts. So let me complete all the data science techniques, and then we come back to the PySpark as well. Okay. Yes, guys, everybody's clear. So this would be your task number. I think I mentioned this one. Let me just 1 second. Morning batch, 10 a.m. Edit with Notepad++. Oops. I think I already given up this one. So here I am going to do project called 14 polynomial. It's a linear or non-linear? It's a linear or non-linear? Non-linear. Very good. So last part I'm pending, which is called gradient descent, Let me introduce to it. Yeah. And then we come back to, I do see that many of people are missing, guys, because they're saying the link issues. I asked someone to, can you please create a steps, guys? Why not you collect, just click on, just link is not working. Yeah, so this is not my problem. Anyway, let me address this issue. Okay. See, guys, from the online team, I request anyone, can you please make a steps? How do you connect to the classes and inform to the others team, please, other members, Avinav, Ashish, Chandramoli, Mansoor, Shiva, Wasim. I told you, right, yesterday. You know this, right? How to, you guys are into online before? No? Anybody attend? How do you attend online, Rahil? Yesterday you attend online, right? So what is the process? You have the login access, right? And then the link is activated. You just live sessions. Yeah, it's very simple. All right. Student panels or live class. Okay, Arshad, can you post the same message to the group? Please. Step 1, log into this account. Step 2, get your login and password. Step 3, go to the student panel. Step 4, click on the live class. Can you do this, buddy? Okay. Yes, you can do it now. In the meantime, you can post this link. Thanks, Avinav, over here. Over there also, you can check this. Just one moment. Okay, just 1 second. So today we completed the polynomial regressions. I am going to talk about gradient descent and all those things, right? Feature selections also we completed. Now, yeah, so let's copy this and paste over here. Just one moment. And login for given. Avinav, can you please write down proper steps and put it over the Zoom so that everybody. No, Pranit mentioned Naresh IT just take the money and then not helping. That's what I saw the message. It's quite interesting. So guys, if you don't log into the Facebook, does Facebook take your money and don't give you help? Just you need to get your logins, Pranit Kumar. No, okay, I'll speak. Pranit, are you there, buddy? No. Just we know. So if everybody is working, just you need to check. This is your responsibility, isn't it? The first time the link is given, it's your responsibility to keep logging your passwords and all those things, right? Abhishek, I already shared notes and MLL codes. Please check. All right. Yesterday didn't post. Okay, he asked day before yesterday. Yesterday only. So I didn't I sent or not? I sent MLR codes. What are you speaking, man? No, you guys are telling me lie. Just one moment. I sent already. Just check. May month. Okay, did you see multiple linear regressions 13th file? Didn't I send this? Sent or not? I sent. You check. No, yesterday polynomial regressions I didn't send. I will send today because I complete today, right? So I will send today. Okay, so he mentioned MLR. Okay, so you're confused, buddy. No worries. Okay, so let's do it. So today we're going to start the first thing, gradient descent. So as we have less time, I will start gradient descent tomorrow, but today I will talk about one concept called normalizations and standardizations. Okay. So these are the feature scaling techniques, but what exactly it is all about, let me explain you. Let's do this. What happened? Any question? Nothing? Okay. So just one moment. So what is normalization standardizations, guys? It is a featured scaling techniques, isn't it? It is a featured scaling techniques. So guys, and one more thing, just one moment. Where is my file? Yeah. So just go back to this one. The first one is normalizations. So the feature scaling techniques are, there's two techniques. One is normalizations and one is standardizations. What exactly the normalizations will do, guys? This is also called min-max scalar. So now, if I have some of the points, thank you, Avinav. So just one second. Did you post? Note. Please get your login access. Okay, I think they have already. Post. Okay, Avinav, I think you already post. I already post. All right. Yeah. So it's not working. So I posted the steps. Okay. No problem. Thanks. All right. So if the age is 24, okay. If the salary is 50, what the scaling is doing normalization? No, when I was in hometown, I forgot, sir. So this what happened, age 24 has converted to 0.5, correct? And 50,000 also has converted to 1. You know, who does this, guys? Who does this? Because this formula, did you see, normalizations is a scaling techniques in which values are shifted and rescaled so that they end up ranging between 0 to 1. X dash equals to x minus x minimum value divided by x max minus x minimum value. I hope you understand. So now, did you see, no need to worry because 10M guys are very lazy. So my one student, she prepared a formula. I will share with you all these formula which are important for you because you guys are not prepared formula. Did you see she mentioned all those things? Let me show you. I already shared you, but many more formulas she added over here. We understood mean. We understand population's mean. We understood sample mean, median, mode, skewness. No need to remember this. Yes, sample variance, population standard deviations, sample standard deviations. When she prepared her, she will be sharp because all the concepts are clear. Because when she write some formula, she have to be follow more than 3 times. Voice is breaking for everyone. Arshad, Avinav, does voice is breaking or clear? Okay. Let me repeat again. So what I was saying about, yeah, what I was saying, just one moment. Just type 1 error, type 2 error, sum of squared errors, right? And covariance, G-score, chi-square test, polynomial regressions. Yes, this is polynomial regressions, right? And also degree of polynomial regressions, x1 square, x1q, and all those things, right? I hope you understand. I hope you understand, guys. Correct? So at this moment, I just wanted to say the two things because just one moment. Yeah. So what exactly, when we mention, right, this one from sklearn, what package we calling for pre-processing? Model selections or pre-processing, right? From sklearn.preprocessing import normalizer, isn't it? Are you doing or not, guys? From sklearn.preprocess import standard scaler, right? Agree? So when I mention these packages, so this formula is called in the backend. These formulas are called in the backend. I hope you understand. So that's what I want you to remember this formula, because here X max and X mean are the maximum and the minimum values of the feature. When the value of X minimum is 0 and hence X dash is 0. So you don't need to worry. Just remember what is meant by normalizations, right? And this is also called, what is standardizations? X minus mu divided by sigma, X minus mu divided by sigma. So this is also used for to scale the data. Do we get 0 to 1 over here? Are we get 0 to 1 in this case? No, we get a standard deviations for the data set. Correct, guys? Maximum time. What is the difference between both? Difference, normalizations good to use when you know the distributions does not follow Gaussian distributions. What is Gaussian distributions? Normal distributions. In normal distributions, what happened? Mean equals to median equals to mode. Understand? So that's why maximum cases we used standardizations because it follow Gaussian distributions. Clear, guys? So most of the use cases we use standard scalar rather than normal scalar. Clear? I hope you understand, guys, what exactly I'm saying. Yes, online, guys? Okay. So this is all about it. I'm sorry. So today I just a little bit came late. Okay. So tomorrow I will cover up. I'll complete gradient descent tomorrow. Okay, guys. Thank you so much. And I will share this immediately.